In this video, we're going to learn how to graph a linear equation in MOER. So here's our context. The temperature of an unplugged freezer is 95 degrees Fahrenheit. After plugging it in, the temperature decreases at a constant rate of 15 degrees Fahrenheit per hour for the next 4 hours. We're given our two variables. Let H equal the number of hours since the freezer is plugged in, and let capital F equal the temperature in degrees Fahrenheit H hours after the freezer is plugged in. So our first question is, what is the initial value of the linear equation that represents this problem? So what's the initial value of the freezer? So when it was unplugged, it was 95 degrees Fahrenheit. Now we're asked to write the initial value as an ordered pair. So remember, there's a relationship between H and F, okay? And it didn't give us a value up here for the H, but you can think of it in terms of H. The initial value is when it's 0 hours since the freezer is plugged in. So at the exact moment that we plug in the freezer. Okay, so it's not nothing, it's the number 0. Next, we're asked, what is the rate of change of the linear equation that represents this problem? So we're told in the second sentence that the temperature decreases at a constant rate of 15 degrees Fahrenheit per hour. So since it's a constant rate, we know it's a linear function, okay, or equation, and it also says so up here. That's another way we know, okay? And we know the change is 15 degrees Fahrenheit per hour. And then notice this says decreases. So if it's going to decrease, that's going to be a negative value. So negative 15 degrees per hour. Now we're asked to use the rate of change in the initial value to find the F value that corresponds to H equals 1 and write it as an ordered pair. Okay, so we're given an independent variable value, H equals 1. Okay. And now let's recall how linear equations work. Okay, so when the independent variable increases by 1, so we go from 0 to 1, the dependent variable changes by the slope. Okay, so this is negative 15 degrees per every hour. So since this is a 1 hour change, it's going to be a minus 15 degree change for the second coordinate. So 95 minus 15 is 80. Now we're going to use these 2 points, this one, which is called the vertical intercept, and this one to plot the line, or graph the line, excuse me. So let's scroll down. Okay. So notice in MOER we're given the line tool. That's what this is. Notice it has 2 red points. You only want to click on 2 points, okay? So there's infinitely many points on a line. Okay, but if you click again, even if you click right here, it's really thinking you're making another line. Okay, and it will mark you wrong even if your lines line up. Okay, so instead you're just going to click 2 points. Okay, and we have our 2 points, 0 hours and 95. So this was the vertical intercept. And then we know after 1 hour, we had an 80 degree temperature. So I click there. And now we have our 2 red dots at those 2 points, and we've graphed the line. Let's look at the next example. Here we're going to graph an exponential equation in MOER. And we have the number of bacteria in a petri dish is doubling every hour. The experiment begins with an initial amount of 10 bacteria. Our variables are H is the number of hours since the start of the experiment, and capital N is the number of bacteria H hours after the start of the experiment. So first, just like the linear example, we're asked for the initial value of the exponential equation that represents this problem. In this case, when the experiment started, there were 10 bacteria. So that's our initial value. And to write that as an ordered pair, remember that that corresponds to an H value, a number of hours. And since it's the start of the experiment, it's 0 hours. We have 10 bacteria. Let's look at the next question. what is the growth factor of the exponential equation that represents this problem? Okay, so since the bacteria are doubling, it's a growth factor. They're not decaying or splitting in half. Okay, and doubling means that for every increase in the number of hours, the previous number of bacteria doubles. Okay, and doubles is the same as multiplying. Since we want a factor, we want to multiply by the factor of 2. Now we're asked, use the growth factor in the initial value to find the n value that corresponds to h equals 1 and write it as an ordered pair. So we're given the value h equals 1. Okay, and now we're asked to find the n value. Now remember, with linear functions, when this increased by 1, the dependent variable increased by whatever the rate of change or slope was. With exponential equations, it's multiplication. Okay, so that growth factor, if we start with 10, 1 hour later we're going to have 2 times as many, or 2 times 10, which is 20 bacteria. Okay. So now we have 2 points, and in general that's not enough to graph an exponential equation. It could be a line for all we knew, but we are graphing this in MOER, and we are using the exponential equation tool. Okay, so this will use the 2 values that we put in to create the correct exponential graph for us. So again, we just want to use 2 points, and so that's what an exponential curve looks like. That's not ours, I just made one in general. And if you need to clear it out and start over, just click clear all. Okay, so we knew at 0 hours we had 10 bacteria, and at 1 hour we had double the bacteria, which was 20. Okay, so here's our graph with the J shape because it's exponential, and we're all done.